So I wanted to go over carbohydrates. And so in this episode, we're going to go over kind of what happens with carbohydrates, why they're important for you as an athlete, and sort of the metabolism behind them. I'm not going to go super in depth on like types of carbohydrates that you should be consuming or types of fuel. I think I'll save that for another episode. What I want to go over today is the process in your body of what's happening when you exercise, specifically things related to CrossFit or just high intensity exercise in general. So this is what I did my entire undergrad on, is what basically why carbohydrates are important. This and fat metabolism. And so you store glycogen in your muscles, you store glycogen in the liver, and you have a circulating amount of blood glucose that just hangs out in your blood. And when we want to do work, we need to use what is called ATP. And ATP, as you can see at the end here, this thing at the bottom, in the bottom right, is the power stroke. That is ATP effectively being the key energy source for your muscles to contract. And you need to do that in order to, your diaphragm is a muscle that contracts, and it basically lowers and pulls air into the lungs. Your heart is a muscle that needs to contract, and then any of the tissue that you use to execute movements or perform work basically are muscles that contract, right? And so they all need ATP, and when you have glycogen, this is like the quickest process to get from glycogen to ATP. It's the quickest and most efficient, because what will happen is, you can see on the top left, we've got glycogen. Glycogen is like a long chain of sugar basically, and there's a bunch of stuff that happens, and you can either get glucose out of it, or you can use the glucose 6-phosphate, turn it into pyruvate and then acetyl-CoA, and perform anaerobic metabolism with it, which is what happens when you train really, really hard. So if you're doing like bike sprints, for example, going over your threshold, you start to use more of the anaerobic energy system. And basically what that's doing is it does create ATP, but it does it at a really inefficient rate. So it uses create ATP, but it does it in the absence of oxygen. But when we have oxygen present, which is usually for most CrossFit workouts, there is some level of like oxygen presence. Really short explosive stuff, not so much, but like a 12-minute AMRAP, you are doing it in the presence of oxygen, at least with oxygen for enough of the duration of the workout that you are performing glycolysis. And what happens when we get those glucose molecules off of the glycogen, you send them into glycolysis, and glycolysis effectively creates ATP. It goes and creates this pyruvate, and then the pyruvate will go into the mitochondria, and when it enters the mitochondria, it goes through this even more detailed thing called the electron transport chain, and the electron transport chain uses oxygen to create a lot of ATP out of one glucose molecule. So this is why this is the preferred fuel source for your muscles, because it's like your body knows that's how you get the most bang for your buck, right? And so anyways, you create all this ATP, and then that ATP goes and is used for work, right? And that happens at the cellular level. So the glucose gets transported to the cell, and then it is kind of moved back and forth over the membrane of the mitochondria to produce a shitload of ATP. Fat is an inefficient fuel source because it's slow, not because it is inefficient. And so why this matters for CrossFit is because most of the work that you're doing would be categorized as unsustainable, and fat does not do a good job at producing glucose fast enough to support that amount of work. And so when we have fat, there's just like a long chain of fat basically, and what happens is you cleave like the bottom of the fat molecule off. You take that little chunk of fat and then you turn it into you have to put energy in, and you turn it into sugar, and then the sugar is then mobilized into the bloodstream and then circulated and then used by the muscle tissues. And when we're looking at fat oxidation, each fat molecule or chunk of fat or whatever, it creates a ton of ATP because there's a lot of energy stored in fat. But it takes a long time to take the fat, adipose tissue, and synthesize it into usable sugar by the body. There are other forms of fuel that can come out of fat. There's like ketones that can be used, but your body generally wants to take fat, turn it back into sugar, and then it'll use that sugar to, go through the electron transport chain to create, ATP. And so what happens is when you go back here, when you use fat oxidation, this whole thing happens here, and it happens slowly because you have to, for each molecule, you're cleaving the bottom little bit off over and over again. Then it's going through, it's getting turned into acetyl-CoA, and then that acetyl-CoA gets shunted into this process here where it is then picked back up. So instead of getting to go from glucose, boom, straight down into ATP through this metabolic process, you have to do a bunch of stuff beforehand to turn the fat into glucose or into acetyl-CoA, that can then be used later on in glycolysis. Okay, so glycogen is stored in the body in muscle. You store 400 to 500 grams in the muscle. Better trained athletes can store more glycogen in the muscle. In the liver, you're storing between 100 to 120 grams. And then in the blood, you've got 5 grams of circulating glucose, not glycogen. So when you start training, this is a really common misconception, especially amongst CrossFitters. Everything happens at the same time. Everything turns on. And your body preferentially selects the process that is getting the job done the best at that given time. All right. So when you go to take that first pedal stroke on the bike, even if you're doing it at zone 2, you will still utilize the phosphocreatine system to execute that first initial contraction, right? Because it's there and it's ready. All right. Then everything sort of kicks on. All right. And then it pushes and pulls from these different, cascading energy system downstream things to support the exercise or the work that you're doing. And so let's say you're going to do a CrossFit workout and it starts with, snatches. You'll use the phosphocreatine system to kind of get the snatches going, right? And then you switch over to glycogen because it's a highly glycolytic exercise. It requires a lot of sugar. You're having to produce a lot of force and you're having to do that contraction several times in a row, all right? And so what's happening is you're using muscle glycogen. And then when that happens, there's cell signals that happen that go on in the body, and your body goes, oh, okay, so we're doing work. I'm noticing that muscle glycogen is coming down a little bit. I'm going to take some of the blood sugar that I've got on circulation here, some of that 5 grams. I'm going to throw that into the muscle to make sure that the muscle can continue to do work because I want to support it, because it does take a little bit of time, right, in the muscle for it to turn glycogen into glucose. So I'm going to kind of support that. Now my blood glucose levels are falling. Okay, when that happens, you also send a signal to the liver and it says, hey, let's get some of that glycogen going from the liver. Let's start putting that guy into the bloodstream as well. And so what you'll notice when people start working out is they'll actually have their blood sugar rise initially, because your body sends all these signals that are like, hey, training's happening. It's getting pretty tough. We need to make sure that we're taking a lot of glycogen out of the liver and putting that into the bloodstream, because we don't know how long this person is going to continue to exercise for. And so we see a slight rise in blood sugar. And then throughout the exercise, you're depleting your muscle glycogen. You are trying to maintain a homeostatic level of blood glucose, but also you're dumping some of that glucose off in the working tissues, right? And so you're using the kind of reserve, I would say, from the liver to maintain blood sugar levels, right? While all that's happening, you will also be doing fat metabolism. It's just it happens so slow. It's not the primary source of sugar and ATP for the body. If you were going to go and ride the bike for 4 hours straight and you could breathe through your nose the whole time, then you would probably use a lot more of the oxidative pathway there. You would be synthesizing fat a little bit more, and it would be easier for your body to maintain a blood sugar level using fat than having to rely solely on the liver, right? And then once we've depleted the usable glycogen, you don't actually deplete it all the way. I think if you were to deplete muscle glycogen all the way, you would die, right? Like your heart would stop contracting. But once you get to levels that are very low, that's when you feel like you're gonna bonk, like your stuff doesn't feel good. You start getting a headache. You're having a hard time managing your blood sugar. And in this instance, fueling becomes really important, right? And so mid-workout, or if you have multiple metcons, if you're going on a long training ride, let's say 45 to an hour and a half of intense training on a bike or a rowing machine or something, having intra-workout carbohydrates effectively takes glucose and slams it straight into the bloodstream, right? And so it's not, there's the physiology gets a little bit hairy here, but more or less what's happening is muscle glycogen is coming down. That's being depleted by intense exercise. Liver glycogen is coming down because you keep taking the glycogen out of the liver and sending the glucose into the blood so that it can dump it off in the working tissues. When we do that, now we don't have to rely quite as heavily, right, on our muscle glycogen because we're getting a little bit of help from the stuff that's coming in from the blood. But then we can also drink Gatorade, we can drink orange juice, eat fruit snacks, do whatever you need to do. And that sugar will get put straight into the bloodstream, right? And then you get even more that comes in and helps so that you delay how quickly we deplete glycogen from the liver and from the muscle, all right? One thing to note here that I see a lot of is like if you're just doing a tough weightlifting session with like relatively low volume, high intensity, you probably don't need to be consuming an excessive amount of carbs mid-session. That work is not inherently super glycolytic. I think really glycolytic exercises are things like metcons, intense muscle endurance training and bodybuilding, so stuff where you're doing high rep sets, where you're getting a really big pump, really intense cyclical work, so biking intervals, rowing, running intervals, any of that stuff. Those all run on carbohydrates. Those are types of exercises that are going to really bias towards wanting to use carbohydrate as a fuel substrate to perform the work. Now, when we do really heavy, intense lifting sessions, especially if they're shorter and lower in volume, or if we're going for really long, slow distances, then we can rely on fat oxidation and phosphocreatine a little bit more. And that glycogen isn't quite as imperative. Your body will do an okay job at supporting that training session with your existing, glycogen and blood sugar, that you don't need to be slamming carbohydrates for the entire session. And so a little bit of that is experimentation, managing intensity, and that sort of thing, knowing yourself as an athlete. But I just wanted to go over all this stuff because I think it is important that we understand what's happening in the body and why carbohydrates are important and the way that they're being utilized in your training sessions and the types of training that really rely heavily on carbohydrate. Okay, so a little bit of a shorter episode. Like, comment, subscribe, follow me on Instagram. Shoot me an email if you've got questions about this. You can DM me on Instagram if you've got questions. Yeah, thanks for watching, and we'll catch you in the next one.